Next topic is the growth models. Do we have some particular growth models regarding or which are showing the growth of a population? There can be two cases. In first case, if the food and space, it is unlimited. If the food and space is unlimited, then the population will show exponential growth. Exponential growth, or which is also called geometrical growth. But if the food and space is limited, जो कि natural case है, if the food and space is limited, then population of a place at a given time will show logistic growth. Now we are going to discuss these two growth models, exponential growth model and the logistic growth model. In exponential growth, when food and space is unlimited, the species grow in an exponential or geometrical ratio. If in a population of size n, then the birth rate are represented as b. If, for example, if the size of a population is n, b is the birth rate, d represents the death rate, t for a given period of time t, then increase or decrease in population size during a time period, that is t, small t, which is dn upon dt, it is given by dn upon dt is equal to b minus d into n. This is b is the birth rate, d is the death rate, n is the population size. dn upon dt shows a change in population in a time period t. Let us consider या मान लेते हैं b minus d. Let us say that b minus d is equal to r. Then dn upon dt will become r into n. What is r? R is called intrinsic rate of natural increase. R is called intrinsic rate of natural increase. And R is an important factor which is chosen for assessing impact of any biotic or abiotic factor on a population growth. Means R is a parameter which is chosen, which is used to assess that what is the effect of biotic and abiotic factors on population growth. For example, if the value of R for Norway rat, it is 0.015. The value of R for floor beetle is calculated to be 0.12, and value of R for human population, which as in 1981, the value of R is 0.0205. The equation for exponential growth, it describes the geometric growth pattern of a population, and it results in J-shaped curve when we plot n in relation to time. यानी exponential growth में अगर हम एक ग्राफ प्लॉट करें with time and population density, then the exponential growth curve, it comes out to be J-shaped, where this is K. K is showing the carrying capacity. We will discuss it. And equation for exponential growth is given by NT is equal to NOERT, where NT is population density after time t, NO represents population density at time 0, R is the intrinsic rate of natural increase, and E is the base of natural logarithm, whose value is 2.71828, or simply it can be 2.71. Any species which is growing exponentially under unlimited resources conditions, it can reach enormous population density in a short period of time. क्योंकि स्पेस और फूड अनलिमिटेड होगा तो कोई भी स्पीशीज, चाहे वो छोटी से छोटी हो, बड़ी से बड़ी स्पीशीज हो, it will show enormous population density in a short period of time. And Darwin also showed that the slow breeder like elephant, it can also reach enormous number in the absence of check. If there is no check, then the population will increase drastically. And in NCRT, the both the exponential and logistic growth curve, they are shown in this same graph. This is this red one, this is showing exponential growth. In the absence of any check, food and space is unlimited, the population is going on increasing, and it is represented by which equation? dn upon dt is equal to rn. So this is exponential growth curve, or the growth model, that is exponential growth of population.